Hey guys, what's going on? In the last video, we reviewed the basics of the JavaScript runtime and the event loop. Now what I'd like to do is to jump into some live coding examples of asynchronous JavaScript. Now you may have heard that JavaScript functions are considered to be first-class objects. This means that they can be stored as variables, passed to other functions as arguments, executed within other functions, and returned from functions, just like any other object. These are also known as higher-order functions. These higher-order functions are a big part of why JavaScript is such a powerful and flexible language, especially in terms of its ability to embody functional program and composability principles. These characteristics of JavaScript functions form the basis of callbacks. So at a basic level, a callback is a function that is passed to another function as an argument and executed within that function. Callbacks are used heavily within JavaScript and can be found almost everywhere. Some examples of places where you may find callbacks would be event handlers such as onClick, keydown, or onload, utility functions such as map, filter, and reduce, AJAX requests, especially with the jQuery library, and in error-first callbacks that we find in Node.js. Perhaps the most straightforward example of a callback would be the callback found in the setTimeout function. Let's take a look at an example. Now setTimeout takes a callback as its first argument and a time parameter as the second argument. All right, now let's give this a timeout of 3 seconds and go ahead and run this. 1, 2, 3. So setTimeout was invoked. It took an anonymous function which returns a console log as its callback, waited 3 seconds, and then executed the callback. Now let's take a look at another example using the map array utility function. So let's say we have an array, constant array1, and this will just be an array of integers, okay, even numbers. Now let's build a second array. Okay. Now we'll map through the first array, and here we'll pass in a callback that will take x, which is the current index of the array being processed, and let's multiply it by 10. Okay. Now let's output array2. All right, guys, so again, in this example, we're looking at the map function. The map function takes a callback function as its only mandatory argument. And so with each iteration over the collection, in this case an array, the callback is fired. So in this case, the resulting array2 ends up being a copy of the first array with its values processed. So, all right, let's take a look at one more example of a callback. This time we'll switch over to a little Node.js application that I've spun up here. All right, so this is just the basic hello version of a Node app. Basically, it's creating a server and returning hello world. So let me quickly go ahead and fire this up. Node app.js. Okay, and I'll bring this up in the browser. Okay, so there's our hello world. Now what I want to do is, let's see. So first of all, we've got a callback function right here. I don't know if you saw it, but http.createServer is taking a callback, and then once that server is up and running, it'll execute this callback code. But what I want to do is probably add another layer here. So we'll do some file processing in this example. So what I want to do is fs, which is file system. Well, first of all, I've got to import the file system. Const fs equals require fs. All right, now I will have to restart the application, but that's okay. So we're gonna read a file in that we have in our project root. So it's called index.txt, okay? And then after that, we're passing in a callback function. Now this is an error-first callback function, which is extremely common in Node.js. The idea here is that your callback basically returns the error and then the payload So within the callback code, you're always checking for the error first and foremost, and then you have an if statement around that error, check for the error object, and so the error code, the error handling code executes if there is an error, and if not, the rest of your program continues on and executes. So you don't need an else statement, just the if. And it'll probably be clearer once I write this example out. Okay. So here's our error handling code. We're going to say if error console log error. And in fact, we can get rid of these curly braces. Let's do a little shorter syntax here. We'll just return it like that directly. And then what I want to do is cut and paste our server response code below this. All right, so if there's an error, the code will run this console log and then return. So this code below it will never get run. If there's no error, it'll ignore this and go ahead and execute our response code. All right, so the last thing I want to do is replace this hello world string with the actual contents of our file. So let's do data to string. Okay. All right, I think that looks good. So let's go ahead and run this code. I'm going to have to save this file and restart the server quickly. All right, so now if we refresh our page, we should see the output of our text file. And there we go. Let's see if this matches the context, and I'm not just tricking you guys here. There we go. So our program has read that file. Again, going back to the code here, we have our outermost callback, which is what's being passed into create server. http.createServer, okay, then our callback code right here. Within that, we have another function being called read file, and here we're passing in our error first callback. All right, guys, so I hope that was clear. Hope you're able to understand my explanation here on callbacks. So next, we want to take a look at promises. So promises can be seen in many ways as an improvement over the callback style of asynchronous JavaScript. Promises provide a more robust and predictable framework for writing asynchronous JavaScript, and they also solve another problem known in the development world as the dreaded Pyramid of Doom. And no, I'm not referring to the 1979 text-only adventure game for Atari and Commodore 64. The Pyramid of Doom can manifest when you have a program with several layers of nested callbacks. In this case, with each indentation, the pyramid grows, and eventually you can end up with code that looks like this. So promises alleviate this problem by flattening the code structure, making it much more readable. So let's take a look at a few examples. Now, the first thing I want to do is to refactor our previous callback example using promise syntax. So the first thing we need to do is to create a promise object. Let's call this promise1. Okay. And since we're creating a new promise from scratch, we want to use the promise constructor syntax, which is new promise. All right. Now this constructor takes a function known as the executor. Now the executor takes two arguments, resolve and reject. Reject is optional. And inside the body of our promise, we'll use either or of these depending on the outcome of our async operation. Okay, so we had set timeout. We pass in a callback to set timeout. All right. And then previously we were doing a console log. So now that we're refactoring this to use promises, we'll resolve here. And let's give it a value of foo. Okay. And lastly, we'll add our actual time value of 3 seconds. Okay. So in this scenario, since we're using set timeout, that's a pretty sure thing, so we don't have to worry too much about errors. So I'm going to delete the reject argument there. All right, so that's our promise code. Now we need to write the consuming code that's going to use our promise. So we'll start with promise1. Okay. Now this promise object contains a special method called then. And the code that we place inside of then is guaranteed to run after the async operation completes. All right, so we can pass this a results object. Okay, we can also optionally pass an error object. However, we're not going to do it in this case. And another thing to note here is that, while the then method can take a results and error, what you can also do instead of passing the error is then chain a catch statement, which maybe I'll show you a little bit later. And that's basically the same thing as passing an error argument to then. And this seems to be the style of how most promises are being written. So let's see, I'm going to use an arrow function here and do console.log results. All right, now I'm just going to clean this up a little bit. Don't need those braces there. And let's go ahead and run this code. So before we run it, what is this going to do? This should basically run our promise, and after 3 seconds, we would expect to log foo to the console. 1, 2, 3. And there we go. So that is working as expected. Okay, now another thing that we can do with this promise is we can actually chain then statements. So just to back up a bit, every promise has a then method that we can utilize, and each then method actually returns a new promise. So that's why we're able to chain these. So let's write up a brief example of that. Okay, so here's our first then. Let's see, I'm gonna break this down to a new line to make it a little more readable here. Now the important thing to remember is to return a value from then so that, if you're chaining it, so that this value gets passed on to the next then block. So we'll say return result. All right, close our brackets. Basically repeat the same thing here. Okay, this time we'll change it up a bit. Return result, and let's just modify the string a bit. So foo, let's say bar. Okay. So you can probably see as I'm typing this out how this sort of syntax would alleviate the callback hell or the pyramid of doom problem that we saw before with callbacks. This looks a little bit closer to synchronous programming. And then finally, we'll do console.log result. All right, let me just take a minute to look over that. I think that looks good. Oh, let's change this to result to match what we're returning here. Return, no typos. All right, now let's go ahead and run this code. Foobar, so there we go. So basically we invoked promise 1, okay, and our promise here returned foo, okay, then that value was passed on to the next chained then statement. So then we augmented that with bar, okay, then that result was passed to the next then, and finally we console logged it. So you can really see the power of chaining then statements. And then just to show you, I mentioned earlier that the then statement can actually take a result and an error argument. But another way to do the same thing basically is to just have one catch at the end. So we could do like catch, catch, and then pass an error like this. Okay. Running out of space here. Okay, close that up, and then, we would do like a console log or something like that. Console log the error. Okay, so that is basically how a setup would look with chained promises and error handling also included. Now, the thing to remember is you don't always have to use the promise constructor syntax that I showed you. Many APIs, including many HTTP libraries and the fetch function, for example, that's now native to JavaScript, already return a promise implicitly. So we can simply call those APIs, call those functions, and then assume that we have access to then and and catch as well. So let's take a look at an example of that. Let me clear this a bit here. Get rid of our last sample code. All right, so let's do, I'm actually going to just copy and paste this example and then we'll talk about it, all right? Because the URL here is a little bit long. You'll see what I mean. So what we have here is a fetch API call, okay? And we're calling just a sample REST API that's going to return some kind of static payload, a to-do list. It looks like a to-do item in a to-do list. So I want you to take a look and notice the structure of how this is set up here. So you notice that we don't have any promise defined. That is because fetch returns a promise already. So we don't need to set up anything new. We don't need to wrap any functions in our promise constructor. We could just call this directly. Okay, so we're passing in the URL, and then we're able to .then this function. Okay, so you may hear people say that it's thenable. Okay, so fetch is thenable. Any function that returns a promise is thenable. It sounds kind of funny to say, but so here we're just, let's see, the response coming back from the server is always going to be a string. So here we're just doing .json, which parses it essentially into an object that we can use in our code. And then we're just console logging it. So let's see if this works. Okay, you saw promise pending. You know, it took a second or so for the async call to go through, and then here's our item that got returned. All right, so good. That kind of shows you the two different ways to use promises, whether you're creating one from scratch or using an API that returns a promise implicitly. All right, so we've seen how we can use the promise then structure to execute promises in sequential order. This is useful when code is dependent on the previous promise's results, guaranteeing that it will be available when that code runs. Now, I'd like to look at another way to structure promises, the promise all method. We can use promise all when we have multiple async operations that need to happen, and we want to run code only when all of those have resolved or completed. For example, maybe you have a web application that needs to reach out to 3 different endpoints to gather different data before processing that data and then building and displaying the page. So in this case, promise all would be really useful. So promise all takes in an array of promises and then returns a single promise with an array of results of those promises passed in. Let's look at an example. Okay, so the first thing I want to do here is to set up a couple of promises that we can then pass in to promise all. So let's do const foo, and for the first one, let's use an immediately resolving promise. So we can say promise.resolve, and let's just do a random number 5. Okay, second one, const bar. For this one, we'll just pass back a string bar. Now, although promise all typically takes an array of promises, they don't necessarily have to be. So we can, if we just, pass in a value such as a string or a number, we can expect that that will be returned as is in the results. All right, and finally, const baz. For this one, let's use the new promise constructor syntax. Resolve, reject, arrow function, closing brackets. Now, inside of this promise, let's simulate a network call by using set timeout. Okay, so set timeout. Use the arrow function here as well. And inside here, we'll say resolved promise. Okay, and we'll give that a timeout value of ½ a second. Okay, great. Now we can call promise all and pass in an array of promises. So we'll say foo, comma bar, comma baz. All right. Now, since promise all returns a promise itself, we can do .then, and we can access the results in here. So let's say results. Okay. Now we can also have a catch block here. That will take an error. And let's just say console log error. Okay. Now the error object that's passed into the catch block is going to represent the error from any of the initial 3 promises. In fact, the first one that errors out. Okay, so if, let's say, bar errors out first, then we'll end up in the catch block here with an error object containing information about that particular error. All right. So inside the then, let's console log results. Okay. All right. Now we should expect our results object to be an array of result values. So for instance, we can access these individually. We can say const a equals results of 0. Okay. Now that is going to give us just the result from foo, since foo is the 0 index of the promise array. So our results array is going to mirror that structure. So our results should hold foo, bar, and baz in that order. So 0, 1, and 2 indexes. And let's console log a. All right, so when we run this code, we should first see a console log of just the foo result. Then after that, we should see the results of all 3 together. All right, so let's run our code. And unexpected token. Oh, I see. Okay, so the problem is I don't have an arrow here after catch error. So I can't just fix it. I've got to copy and paste this and open a new browser, because what's going to happen is, since I've done this in in Google Chrome DevTools, it's going to complain about the variables that I've already defined. So I've got to open a new window here. All right. So hopefully I've got no more mistakes here. All right, let's run this code again. Let's give this another try. There we go, much better. Okay, so the 5 again is the console log a, so the results from foo, and then this one right here, contains all of the results. 5 bar resolve promise in the same order that we passed in our promises. All right, so I'll tell you what, let me just quickly demonstrate an error scenario. So I'm going to, again, copy all of this, open up a new browser, clear this out. Let me paste this here. Now, instead of resolve, let's change this to reject. Okay. And we'll send back an error. So we'll say new error. And let's say rejected. Okay. All right, we can leave this for now. Okay, so in this scenario, we should get no results. This code shouldn't run at all. Basically, our execution will end up in the catch block and output our error. So let's give this a try. All right, and there is our error. So error rejected, and that corresponds to the string that we passed in here to our error object. All right, guys, so the next stop on our journey through the wonderful world of asynchronous JavaScript is the long-awaited world of async await. See what I did there? Async await, introduced in ES7, is the most recent approach for writing asynchronous code in JavaScript. Async await, built on top of promises, further flattens the code structure and makes code look almost exactly like synchronous code. All right, so the first thing I'd like to do now is to refactor our previous example to use async await. So let me go ahead and paste that here. All right. Now, to use async await, the first thing we need to do is to add the async keyword before the function definition. So we'll do async function, and let's call it getData. Okay. Now, the asynchronous code is usually implemented inside of a try-catch block, so let's go ahead and set that up. And we'll go ahead and console log our error. All right, now the async functions always return a promise. And if we ever return any code from this async function that isn't a promise, then it'll be automatically wrapped in a resolved promise behind the scenes. Okay. Now, our call to fetch will happen in the try clause here. But the first thing we need to do is to set up a placeholder for our response object. So let's do const response equals. All right. Now here is where we'll use the await keyword. So we'll do await, and then I'm just going to copy and paste our fetch here from the previous example. There we go. Now with the await keyword, this basically guarantees that any line of code after this line will not run until our fetch returns. Okay, so in that sense, it's kind of similar to the then method of promises, only more concise and easier to read in code. Okay, so since our response coming back from the server will be a string, we want to parse it to JSON. So let's set up another placeholder for that. Okay, and again, we'll use the await keyword, and we'll do response.json. Okay, so the use of these two keywords, in other words, guarantees our code structure or our order of execution. All right, our fetch is going to happen, and then the next line of code is not going to run until that fetch returns some data. Finally, let's go ahead and just console log our data. All right, that looks good to me. Now let's go ahead and give this a try. So we'll call get data like that. All right, and there is our data being logged to the console. So as you can see, there are a lot of potential benefits to using async await. We avoid the pyramid of doom. You know, our code is more concise. It looks more like synchronous code, and it's overall easier to code and maintain. All right, guys, thanks a lot for watching, and I hope you found this lesson useful. If you'd like to see more content like this, please don't forget to like and subscribe, and I'll see you guys in the next video. Take care.